to planning, designing, and implementing of large-scale data centers and security operation centers for our customers. And, over the next 30 minutes, I'll share how we've leveraged OpenStack as well as the larger FOSS. Some noise in the background. I don't know where that's coming from.
It would be helpful if people are muting themselves. Okay.
Yeah, thank you very much. So I'll just share, how we actually leveraged OpenStack and the larger FOSS ecosystem to build and operationalize cyber ranges. And I'll talk about what is a cyber range. I'm so sorry. I could be potentially preaching to the choir here, and there'll be people who know much more than me. This is the first time I'm ever attending an open infra session, and I just felt like, I had requested if I could share my experience with everybody so that, everybody gets to know that with the power of FOSS and OpenStack and how we've leveraged it to build something very, very interesting. So cyber ranges, basically they are responsible for creating realistic on-demand environments where cybersecurity defenders can test their skills, and cybersecurity attackers can simulate threats, and everyone can learn in a very safe environment without bringing the house down, without bringing their production network down. What I'm about to present is not just theory. It is a real world implementation that we have done for a very large customer that's being used today in defense, in academia, in enterprise settings. And it showcases the power of open infra to solve complex, high impact problems. So without further ado, I'll just jump in if that's okay. And if we have some time in the end, we can take questions if that's okay with everybody.
Yeah, Abhijit, please go ahead.
Thank you, Ajay. All right, so let's start by looking at the problem statement and what are we trying to solve. Now, there's this organization called ISC2, which says that it's a cybersecurity governance organization that says that more than 3.5 million unfilled cybersecurity jobs exist worldwide, 3.5 million. And the numbers keep growing, whereas, meanwhile, cyber attacks are increasing by 38% year over year globally. And the nature of the cyber attacks also keeps on evolving. The problem is that traditional cybersecurity training often focuses on theory. It focuses on training soldiers by making them read books and giving them canned scenarios and without giving them an actual gun to fire. So they don't reflect the reality of modern day cybersecurity attacks. We expect and just give some context. Whenever in cybersecurity, when somebody says blue team means defenders whose job is to defend a cybersecurity system, and the red team is an attacker, and a white team is a judge, right? That's the terminology that's used in cybersecurity. It's important to set that context. Blue means defend, red means attack, and white means judge. So we expect, typically any CISO or Chief Information Security Officer worth his salt would expect that blue teams and red teams will protect their critical infrastructure. But we don't give these blue teams and red teams realistic environments where they need to practice and build their muscle memory as to what do they do when a breach happens, what do they do when a cyber attack happens, what do they do when an enterprise-wide ransomware attack happens. That is why we need a cyber range. A cyber range is a safe, controlled, realistic environment where teams can train, experiment, and fail without consequences. Or as I like to say, that you can't fight tomorrow's battles with yesterday's trainings. And this is where open infra shines. It enables us and enabled us to create those environments for our customers. At the end of the day, this platform is able now, what we've been able to build, it is able to create repeatable, combustible, emulated, simulated, virtual, as well as physical environments which closely mimic an enterprise network or an enterprise setting where cyber attacks can be deployed and the blue teamers can defend against them and the red teamers can launch penetration testing attacks against the blue teamers. So what is a cyber range? At its core, it's a simulated, isolated environment that mimics real-world networks, systems, and user behaviors, where you can launch attacks, defend against them, and test your response strategies safely. Teams that carry out these attacks are called red teams, where attackers simulate real-world threats, and blue teams can defend and respond to them in real time. You can run capture the flag competitions where participants hunt for vulnerabilities and flags under pressure. Right? They're supposed to, these capture the flag competitions mimic what would happen in the real world. Or you could train incident response and see now what will you do? Now an attacker has penetrated you in your thousands and thousands of virtual machines that exist in your network. How would you go about, responding to it and remediating it? How would you detect? How would you contain? How would you recover from these cyber attacks? The key is that it feels realistic, high fidelity, but no production systems are ever harmed. The best analogy that I can think of here is a flight simulator. Just like pilots train in realistic scenarios before flying real planes, cybersecurity professionals can train here in a cyber range before facing real world threats. But as valuable as they are, cyber ranges are also notoriously hard to build. On the technical side, you need to create complex and dynamic topologies, right? Which are like digital twins of production networks, often on demand. Networks, servers, app server, web server, DB server, particular versions of operating systems, particular versions of firmwares, attacker machines, defender dashboards, fake internet, fake YouTube, fake Twitter, fake Facebook. All of this has to look realistic. You need to simulate not just the attackers and defenders, but you also need to simulate user noise so that a defender does not see only attacker traffic on the network. He sees random noise, which is very closely mimicking the real world scenario. So background traffic, behaviors, etc., that make detection hard. It all has to be fully isolated. At the end of the day, you're deploying real malware, real viruses into the system. So you want to control the blast radius and you want it to be fully isolated from production networks, but at the same time, it has to feel real. And you need the ability to reset and replay the scenarios at will, right? You have to keep making them practice a so-called war game, like in defense parlance or in army parlance is a concept referred to as a war game, so that you're better prepared to handle what will happen when there's an actual war. On the operational side, we talked about the technical side, no? But even from an operational side, building this from scratch can be prohibitively expensive. And many vendor solutions are proprietary, are rigid, are hard to extend, or locked into a particular vendor ecosystem. We needed a solution as a bedrock for our cyber range that was realistic, that was scalable, that was flexible and affordable. And that's why we turned to OpenStack and FOSS, which is free and open source software. And that's what our success story was. So why did we choose OpenInfra and open source as the foundation? First, it's open and extensible with a very vibrant community. I can't tell you how many times I've depended upon the OpenStack discussion forums to take this support and guidance when I've been absolutely stuck in trying to troubleshoot Cola Ansible and other variants of other variants of OpenStack that I've deployed. It's an incredibly helpful and vibrant community that's behind it. And the best part is we're not locked into any one particular vendor. So we have complete control to customize the platform to our needs. Second, it's proven at scale. If we had to build a software that could launch 7,000 virtual machines in a matter of 4 hours, right? That's the scale that we were talking about. The same OpenStack components that power major public and private clouds can handle even the most complex cyber range environments. Number 3, it provides all the orchestration primitives that we needed. Nova to create VMs on demand, Neutron to build and isolate networks, Glance for images, and Ceph for scalable fast storage. And finally, it allowed us to integrate easily with other FOSS tools like Wazoo for a SIEM, Suricata as an IDS, the Hive, OpenVPN, LDAP, all these tools which are essential parts and moving components of a cyber range. Every one of them could be seamlessly integrated into the flow using basic concepts like cloud init, firing metadata on the metadata service that Neutron exposes. It turned out to be a breeze to implement those portions. So in short, OpenInfra gave us the flexibility, the scalability, and the cost efficiency that proprietary solutions could not have. We would not have even fathomed implementing it on an on-premises infrastructure, based upon paid hypervisors and paid cloud platforms. It was OpenStack and OpenInfra that enabled it for us, and I thought it's worth advertising to tell everybody that this is what we were able to do thanks to OpenStack. Now, here's the architecture at a high level. At the core is OpenStack. We use Nova to spin up VMs. We were using a bit of Magnum, but we stepped away from it because containers wasn't a use case immediately for us. Neutron is used to build isolated and even deep fake networks, fake internet of sorts. Glance is used to store and deploy pre-built images, and Ceph for fast and distributed storage. Now, we had a requirement for object storage for which we depended upon MinIO, but we used Ceph primarily for RBD mount points so that we could deploy clones of virtual machines faster. On top of that, we provision and integrate FOSS tools like Wazoo for SIEM, Suricata for IDS, the Hive for incident response orchestration, and so on and so forth. And then we also layer in user access through OpenVPN. So even OpenVPN orchestration is customized. So assume that 1,200 people log into the platform, and these 1,200 people are divided into 12 blue teams, 100 people in each blue team. The entire process of user provisioning using OpenLDAP and the provisioning of VPN connections using OpenVPN, that too is automated completely. So that's what we were able to do. Then Guacamole, was used to provide beautiful, high fidelity, very fast interfaces wherein anybody could access a Kali interface or a Ubuntu interface or a Windows RDP using just their web browser. We exposed NoVNC and Spice underneath for hypervisor level console, but Guacamole provided really good quality interfaces over our web page. And the stack, what you're seeing in front of you, it gave us full control, high performance, and seamless learner experiences. Anybody who was participating in cybersecurity learning exercise, he was not bothered about what is happening underneath. He just had one single web page to access the entire cyber range. Now, when we set out to operationalize our cyber range, infrastructure as code was central to our philosophy, because we wanted repeatability, scalability, and full control over our deployments. The logical choice for us was Heat, which is OpenStack native. But given our use cases, the way we had to deploy multiple images, some of which were friendly to the OpenStack ecosystem, some which required rebuilding from source code, things like Vios and OpenSense and those kind of images, we felt that Heat turned out to be a little too rigid for complex workflows. We evaluated Pulumi as well, which is developer friendly but not very widely adopted, so that was a risk. Terraform, which stood out for its maturity and multi-cloud support, but then finally the implementation was we implemented a Python and fast API layer with which we directly consume the northbound API of the OpenStack SDK. Why? Because it's granular. It gives us multiple levels of detail and flexibility. It's extremely powerful, and it gives us the fine-grained control over every single aspect of OpenStack, be it compute, network, storage, or security, which was critical for our early stage development. Now, as the product matures, today we are transitioning to Terraform so that we can write code once, and the same Terraform script, by just changing provider specific settings, can be offered to cloud agnostic environments and serve clients beyond the OpenStack environments as well. In other words, we started off with flexibility, which OpenStack provided us and OpenStack SDK provided us, and now we are moving towards universality. Now, using OpenStack's orchestration capabilities, today we are able to spin up entire training topologies within minutes. Nova provisions all the VMs, the attackers, the defenders, the observers, the user noise dynamically on demand. Neutron today allows us to create isolated networks for each team, blue, red, yellow, white, while still enabling interzone communication through pfSense or Vios, or sometimes we even stick to using security groups inside OpenStack along with just the OpenStack router. We simulate a fake internet, so we launch attacks from different parts of the world, different countries, with cloned services like Mastodon. If you've heard of Mastodon, which is a Twitter clone or a YouTube clone, or even, geolocation based attacks can be launched, fully isolated, yet very, very realistic. Ceph is our workhorse. It powers the boot from volume. It allows us to launch virtual machines quickly and even roll back to known snapshots between exercises. The result is a fully orchestrated, completely isolated, yet very realistic playground for cyber defense and cyber attack training. Sorry for the small font, but I wanted to kind of give you perspective of the features that we built on top of OpenInfra. Now, on top of the OpenStack and the OpenInfra, we built a powerful set of features and learner-friendly features that transform the raw infra into a seamless training platform. Users can access their VMs via a browser-based NoVNC console and manage labs through an intuitive drag-and-drop lab manager interface. So when I say drag-and-drop lab manager interface, think of a modeling engine. You drag and drop, different kinds of, virtual machines on an interface, and that interface then spits out a YAML. That YAML then gets fed into our, YAML to OpenStack engine, so to say. And then that engine basically deploys the entire cloud for us, right? We support multiple exercise modes. For example, we support red team offensive scenarios, blue team defensive scenarios, combined attack and defense scenarios where your job is to protect yourself also and launch cyber attacks on other team members also, as well as capture the flag competitions. To make orchestration even smoother, we developed a concept called Actions Manager. Now, what is Actions Manager? It's basically, Ansible on steroids. It's a one-click deployment system based upon customizable Ansible playbooks that consume exercise-specific runtime variables. So think that you've got 7,000 virtual machines, 100 blue teams, and for every single blue team, you want to deploy a web server, an app server, a DB server, a WordPress instance, and a mail server, right? And this Actions Manager is basically responsible for giving you that entire structure. You just feed in the specific information that you want, and it will deploy it across all the 100 teams. Interestingly, it doesn't ask for IP addresses. That's a separate microservice that we developed that talks to Neutron and manages it via an IPAM. So the user who's creating such labs does not even have to be bothered about IP addresses. The entire heavy lifting is done underneath. Now, to enhance realism, we provision a fully isolated but realistic fake internet, including cloned services, like I said, Twitter, YouTube, etc., and the ability for attackers to appear to originate from different geolocations. So even if a defender tries to block attacks using rule-based access controls or ACLs, it becomes ineffective because the next attack could come from any other country, very similar to what happens in denial of service attacks in the real world. Access to the entire platform is simplified using, as I said, OpenVPN and Guacamole, and authentication is via central OpenLDAP. All of this runs 100% on OpenInfra, showing just how far you can extend free and open source with a little bit of creativity and engineering. What does the learn experience look like? We designed the learn experience around structured, realistic rules. So, for example, the red team takes on the roles of attackers. They are responsible for planning and launching offensive actions, and then documenting them and submitting them in the form of attack reports. The blue team acts as defenders. Their job is to monitor and detect and respond to threats and submit incident reports and situation reports. The yellow team injects background user noise to simulate a messy, unpredictable kind of an environment for real users, which makes detection and defense even harder and more realistic. Now, remember I said the white team is a judge. So the white team gets this big, massive God's view, Sorry, double checking. Am I still audible?
Yeah, Abhijit, very much. Please continue.
Yes, you are.
Okay, thank you. So the white team is basically, they play the role of observers and judges. They oversee the entire environment with a God's view kind of an interface. They know exactly who's launching what attack, who's been compromised, who's down, who's up. They evaluate, they go through the scores, and then they're responsible for giving marks to the red team on how effectively they've attacked, and they give marks to the blue team on how well they've defended. Every single action is logged, everything is analyzed, and we align every single scenario with the MITRE attack framework, ensuring that exercises reflect real-world adversarial techniques. This structured, immersive workflow keeps learners engaged and is focused on their roles, their actual roles as their day job, while fostering collaboration and accountability. Right? So people can give marks for honeypots. If I'm a blue teamer and I find out that an attacker is trying to attack me, I can spin up a VM on OpenStack, which will be a clone of my web server, basically tell the attacker to attack the honeypot, and that way I can get to know the TTPs, which is the techniques, tactics, and procedure of the red team, so I can block them effectively. Very real world kind of scenario. So coming to real world, how does all of this come together in the real world? We've deployed this range in several domains. We've deployed this in defense and military establishments, where it's used to train, national level cyber defenders, simulating advanced nation-state level attacks and teaching response strategies. In academia, universities are using it as a part of their cybersecurity curriculum, giving students an enhanced, hands-on, safe environment to learn cybersecurity skills, and even driving research on any new attack patterns or any new defense techniques. And in the enterprise world, our platform is helping SOC teams. SOC is Security Operations Center. It's helping SOC teams practice blue team drills, improve incident response readiness, and demonstrate regulatory compliance, DPDPA, GDPR, CERT-IN, all these compliances through documented exercises. And all of this was made possible affordably at scale, thanks to this community, thanks to OpenInfra and the FOSS ecosystem. This is what makes me proud of working in this space. My hobby used to be to dabble around with OpenStack when there was not much work given to me before I became an entrepreneur, and I realized that skill that I learned as a part of the ability to implement private clouds has come such a long way that as an organization, my company, Zindagi Technologies, is able to deliver real impact where it truly matters. I have 2 slides more left. So I think I'm on time, I believe, so should be done by 5 minutes. Key lessons learned. So before wrapping up, let me share with you a few lessons we learned along the way. Number one, the OpenStack SDK is incredibly powerful. It gives us unmatched control, which was critical during our early stage deployment. Number two, Ceph is not just a nice to have. It's well integrated and well married to OpenStack. It is absolutely essential for fast VM boot up times and reliable snapshotting. And of course, I have to say, it requires a lot of tweaking and configuration to make it just work just right for our environment. There were times when we spent around 1.5 months to figure out why is it that a Windows 2022 virtual machine is taking close to 9 minutes to boot up. And then we had to go through this performance tuning configurations on Ceph and OpenStack, and using only SSDs, not even NVMe drives, using only SSDs, we were able to bring a Windows virtual machine up in less than 1 minute, only SSDs, right? So there's a lot of tweaking that's required. So Ceph is definitely a nice to have, but requires a lot of tweaking to work well in this entire ecosystem. At least that's what our learning was. Number three, plan your storage and network topologies as early as possible. Both are fundamental for learner experiences and can become bottlenecks if overlooked. So measure twice and cut once. That topology has to be well thought of. You have to think of which all VMs are compatible with Cloud Init, which are not, which all VMs can talk to Ansible using WinRM or SSH, which cannot, and those kind of challenges. Number four, remember that cybersecurity learners, they don't care about your infrastructure. They don't care about the kitchen. They're more bothered about the restaurant. They care about their experience. So the infrastructure has to be kept as invisible and as seamless as possible so that the learners can focus on their learning. Anybody can go to, I don't know, Richmond Street, or in Delhi, there's Nehru Place, and, you can buy a nice, juicy, 64 core, or computer, and then build your lab around it, right? But that's meant for the uber geeks. For the rest of us, we require the ability to learn cybersecurity in a safe, controlled environment, and we want the infrastructure to be just like oxygen. It is critical, but we can't see it. And finally, don't underestimate free and open source. It's viable, it's scalable. There are a lot of naysayers who will speak otherwise, but I believe that it's more than ready for enterprise-grade deployments. Bottom line is focus on learners and let OpenInfra powered stack deliver quietly. That's what my learning's been for the past 2 years now, that I've led a software development team of exceptionally talented engineers who we had to teach. They were amazing in Python and they were amazing in development, but we had to teach them everything about OpenStack. We had to teach them everything about cybersecurity concepts and all that. And now we've been able to deliver a beautiful product, and I wanted to share it with all of you. Finally, why does OpenInfra matter? It enabled us to build a cyber range that is realistic, that is scalable, that is open, that is extensible. And it helped us deliver a seamless learner experience, which is what really matters at the end of the day. So let me leave you with this thought that that open source and open infra aren't just good enough. They aren't just good enough alternatives to COTS platforms. They're transformative. If nothing else, we are a testament to the fact that we were able to train the defenders of tomorrow because of the openness that Open Infra provided us today. And that, I believe, is something that this community should be very proud of. That brings me to the end of my talk. I humbly want to thank you for listening to me and for being part of this amazing Open Infra community. And thank you, Ajit, for inviting me for this. I believe the Open Infra community makes projects like ours possible. I would love to take your questions now. And if you'd like to connect later, I'm flashing my email address and my LinkedIn profile. So, yeah, let's keep building together, everybody. Thank you.
Thanks, Abhijit. Wonderful session and a wonderful use case as well. So it was quite interesting to see how cybersecurity is a very important use case, and your team has been able to crack this use case with creating such a realistic simulation environment. Wonderful, lot of insights. I think most of us listening would love to see it in action once. At least I am very curious to see how this setup works in real time. So opening up for any questions for Abhijit. Anybody?
Is this platform available for outside of these organizations as well?
The platform that we
can cyber security enthusiast myself.
Yes. So as we speak, we are commercializing this, and currently our market has been academia, enterprises, and defense customers. Today, as we speak, we are working on a platform called BattleGrid. So BattleGrid is basically our marketing so-called name for the platform, which basically today is running on GCP. But if you, like I said in my presentation, we are redesigning it to work not using tightly coupled OpenStack SDK APIs, but we are now building. So our code today consumes lab inputs using a JSON, converts that into Terraform code, and that Terraform code today is basically an interpretation of the original OpenStack SDK code that we've written. So given that when we wrote the entire launcher that we wrote was completely coupled to OpenStack SDK, it wasn't capable of running on any other cloud. God willing, by December this year, we are launching BattleGrid, which is the same platform but available as a B2C model. So think Udemy, or if any of you are aware of a website called codecloud.com, K for code, K for cloud. So think CodeCloud or Udemy, but it's basically aimed at cybersecurity, where you basically get curricula, entire curriculums along with courses, modules, and every module is coupled with a cybersecurity lab. So nothing out there today. I could definitely show a demo of what we've done, like on premises, what we've deployed in our small lab that we have inside our office. That's something that I could definitely do. But I mean, if you could wait till December, we'll be launching then with a few courses like open source intelligence and forensic analysis. These are our first two courses that we'll be launching by December timeframe.
Thanks, Sanjeev. This was wonderful talk.
Thank you, Madam.
Any other questions, or we'll move on to the next session? Anyways, Abhijit, hope you have the email ID shared, right? So people would have noted it down. If anybody wants to reach out to Abhijit offline, yes, I can also help you. I have the coordinates.
I've dropped my email ID in the notes.
Sure. Great.
Sanjay Kumar Jain from Nasik.
Yeah,
Hello.
Yeah, please go ahead.
I have two questions. One is that I am a faculty. Can we do this for our students as a mock exercise or learning exercise?
So when you say do this as in cybersecurity, yeah. Sanjay sir, yes, of course. I mean, I would love to understand what your requirements are better. The platform is capable of simulating, cybersecurity learning and training sessions, and that can be converted into lessons that you as faculty or your faculty can then basically impart to your trainees, and those trainees can then basically participate in the cybersecurity exercises. And as a response from a faculty point of view, they get visibility into the scores, that how well is every single trainee performing. So that's something that we can definitely do. If that's something that interests you, I would love to speak to you and understand how we can serve your needs better, sir.
Let me just give one part of it quickly. See, our students are third year engineering or second or fourth year engineering. We don't want the complete curriculum. We just want to introduce them to few of the such scenarios.
Got it. And sir,
I will like to get your email ID and then we can speak more.
Yeah. So I've just flashed my email ID in the chat group, so you could see it there in the meeting chat. So we can definitely speak about it. So I'd love to work with you on this.
Thank you, Abhijit sir.
Thank you.
Thank you. Thank you, Abhijit. We'll move on to the next session. If anybody wants to drop off, please feel free to drop off, or no problem, you can continue as well. So next, we'll move on to the next session from Likhit. Likhit, over to you.
Yeah, Ajit. Good afternoon, everyone.
I think, yeah, able to see your screen. Please go ahead.
Before starting, I would like to give a short introduction about myself. So, my name is Likit. So, I'm from Bangalore. I'm working as a cloud engineer in a company, Nakasra. So, today we'll be seeing what is Sendlin, how to work with it, and I'll also demonstrate a demo how to create a Sendlin cluster, attach some basic auto healing policy, and load balancer with auto scaling. Okay, this is our agenda. So we'll be seeing this further, like introduction to Sendlin architecture and more. Introduction. So what is Sendlin? Basically, Sendlin is an OpenStack clustering service. Using it, we can create a group of homogeneous resources such as virtual machines, stacks, and even Docker containers. Sendlin provides built-in support for scaling, healing, and even updating resources in an automated and smarter way. So the if you see Sendlin, the two main components are policies and profiles, which will be seen further. This is our high-level architecture. So here Sendlin client is a Python SDK, which we must install in order to communicate with Sendlin in any of our client machines. So Sendlin API is the one which collects the request from the client via REST API and sends it to the Sendlin engine via RPC. RP is a protocol which passes the function or some execution from one server to another via network. In this architecture, Sendlin engine is one of the main important thing, like where all the workloads will be executed, where all the clusters, profiles, policies, everything will be executed and be running. If you see the difference between profiles and policies, profiles is nothing but a template which tells Sendlin how to create a cluster. In profile, we'll be defining parameters such as the node name, flavor, network, key pair, etc. So there are three types of profiles such as OS node server, which is our instance virtual machine, and each stack orchestration, and Docker containers. Today we'll be seeing a demo on how to create a Nova VM cluster. Policies is like, in simple words, if you say, policy is like a rules and regulation for a cluster. Like, it defines the cluster, like what it should do, at what point what it should do. So all those auto healing, auto scaling will be done in this policy. So it makes Sendlin really intelligent. Like instead of just statically running a Sendlin cluster, it can adapt to all conditions. Like suppose you deployed your application in a Sendlin cluster, you don't want to run all the nodes every time. Like you can make auto scaling policies, like you want to maximize the running nodes from 9 a.m. to 9 p.m. because many users may be using, and again scale down to like 2 to 3 p.m. 2 to 3 nodes when non-working time. So multiple policies can be attached to a single cluster and they can work together as a group. Where and why to use Sendlin? So maybe so Sendlin is very useful for people who are deploying their application or websites. Why? Because suppose a user has deployed his application in a Sendlin cluster which has 5 nodes, 5 minimum nodes, 7 as a desired, and 10 as a maximum. So in that 7 nodes which is running, suppose if 2 nodes are down, what Sendlin does is, it without affecting the working Sendlin with zero downtime, it automatically builds the 2 extra nodes which was being destroyed. So Sendlin can easily work with and communicate with Nova or telemetry service, Octavia and Key. Where it's used. it can be, as I said, it will be very useful when you're deploying some business application, automation for like in case you don't want to manually scale down or scale up, you can just automate it using some policies. And disaster recovery, as I said, with zero downtime, it will easily scale up the destroyed nodes. Let's go on to the demo. I made the theoretic part with less because demo may take some time, like creating of clusters. Okay, we'll be seeing how to create a cluster, how to attach an auto healing policy, and we'll simulate, like we'll delete one node and we'll see how the node is getting created automatically, and then load balancer with auto scaling. First, let me source my OpenRC file. So the first thing after sourcing the OpenRC file we'll be doing is creating a profile. As I said, profile is the main thing for creating a cluster. It defines how the cluster should be created. This is my YAML file. If you see, I have mentioned like OS Nova server, like I want virtual machines to be created in a cluster, and the name of the nodes which will be running in a cluster, Selenium, and the flavor and image. This is my own customized image which will display some sample web page with its IP. And this is my key pair, network, and security group. Now I'll create a profile using this. I'll name the profile as Selenium profile. Yeah, we can see that the command has been executed successfully and the profile has been created. Let's ensure it. Yeah, the profile is created successfully. Now we'll be creating a cluster using this profile. And give the desired capacity to minimum size as 1, maximum size as 3. They'll name the cluster as Selenium or Selenium cluster. Syntax issue.
Should be max size, I think. The switch.
Right? Desired is 2, minimum is 1.
No. It shows the option as max hyphen size.
Okay. Got it. Now we can see that the command has been executed and the status is initializing. this may take quite few minutes, like 1 to 2 minutes. Let's see this. Yeah, the status is created. That time, let's check whether the nodes are getting created. You can easily list out the nodes by using this command, cluster members list, and then cluster name. It's still in create. By the time it gets created, I would like to say that the reason why OpenStack developed this Zenlin was before OpenStack was using P plus telemetry service, telemeter for like orchestration and monitoring, but that wasn't fulfilling the requirements such as auto scaling. They were not able to do the proper auto scaling, so they later decided to develop a separate service just for like managing group of servers, in which the users can easily perform auto scaling, which is Zenlin. The status is still in building. You can see that the nodes are still in the field row.
Ligit, one question. Can we create this cluster from the Horizon dashboard, or it's just have to be done by CLI? Ajit, I got dropped off.
Yeah,
Is it like
sorry.
1 hour?
Yeah, that
Yeah,
was
okay.
16 minutes. Actually, I had another team's enterprise.
Okay.
Unfortunately,
Can you join me? Yeah, I joined again. Too busy.
Actually, sorry for the inconvenience.
that's okay now. Likit, you can continue.
Yeah, Anand sir was asking some question. Sir, can you please repeat it?
Yes, my question was mainly, I mean, since you are doing all this commands via CLI, I mean, whether this OpenStack dashboard supports creating the cluster, or we have to do it using the OpenStack CLS.
Yeah, we can use it, create it using Horizons.
Horizon also. Okay. Yeah. And the nodes that you're saying, it is just the VMs, correct?
Yes.
Okay.
The cluster has been created.
Likit, can you be louder a bit? I think you're away from your.
Yeah. 1 minute.
Little louder. Not able to hear it clearly.
Is it audible now?
Yes, clear now.
Okay, we can see that the cluster has been created successfully now, and it's active. Now, let's try to attach auto healing policy to it. This is my YAML file where I have written my auto healing policy. Created. We have successfully created the policy. We have to attach the policy to the cluster. I have created a policy with the name VM Auto Healer. Attach we'll attach it to the cluster, Zenlin cluster. It shows that request accepted by action, which means it is successfully attached. Let's check the binding list of the cluster. We can see that the policy is successfully attached to the cluster, Zenlin cluster. Now, we can see that currently 2 nodes is successfully running. Now what we'll do is we'll simulate and check whether the auto healing is working properly by deleting a node. What we'll do is we'll go to the Skyline dashboard and delete one node. Yeah, deleted. So as per the auto healing policy, there is a rule that the interval can't be lesser than 60 seconds. So only after 60 seconds, it will check whether there are two in the minimum or the desired node is running or not. After 60 seconds, if the node is not there, it will try to create one more node. Sorry. In server list, we can see that there is only one node. But when we are checking the member list, we can still able to see 2 nodes because the interval is, as I said, the interval is 60 seconds. It will take 60 seconds to check and then it will try to create one more. Yeah, we can see that another node has been come up and it's in build progress. The status isn't recovering. This shows that without the zero time downtime, this policy keeps on checking and within 60 seconds, it makes the node again back up. I mean the destroyed node. Enable. Tactic. So this means that the auto healing policy is working properly and attached to the cluster. So whenever any node goes down, it will automatically rebuild the node. Okay. So this is what auto healing. Now let's go to the load balancing auto scaling, where the cluster will be attached to the load balancer and all the nodes will be automatically added to the load balancer members. So whenever any new cluster is added or removed, it will automatically update the load balancer members, listener members. I've created a directory for you. So here I have created 2 files. One is the YAML file which contains all the policies which should be attached to from the load balancer to the cluster, and another is a PowerShell script which will collect all the details from the user, and then using those details it will create those load balancer and stack. Let's execute this. This script was just designed to make the user friendly. Like instead of going and entering the variable values, we can just directly select the values using some like one list in list format. that it's fetching the cluster. We'll select one. This is the cluster we want to add to the load balancer autoscaling. Fetching subnets. It is asking to select VIP subnet. So when load balancer gets created, we all know that it will give one VIP, right? By which we can access all these clusters. So we'll be selecting our external network. And then it's asking for select pool network, which is internal. You have to select one because this is the internal network. And finally, we are giving a name for the stack. Deploying fit stack. Okay. This will take quite 4 to 5 minutes. By the time, if anybody have doubts, I'm ready to answer. Love to answer.
Can you show in Skyline how this is progressing?
Yeah. You can see that the first thing which is executing is stack. What this stack will do is, it will create LB policy, receiver scale-out policy, which was mentioned in the policy which I have shown. And this will start creating a load balancer. You can see that it's still an offline because it's still creating. We already got our external IP. So this is what happens. First, the stack gets created, and followed by that, it will create a load balancer and add all those. It will attach the cluster to this load balancer. Yeah, it's online. Maybe it will take some more time. Still in progress. Yeah, we can see that the listener has been successfully created. Still, the members need to be added. One of the node has been added. We'll wait till another one, sir. Yeah. For the success. It successfully. It shows that the stack has been successfully created. Let's check whether this load balancer with auto scaling is working properly or not. Check this side. So as I said, I have a customized image which will just display the IP of the machine. So here you may have doubt like why is this showing this IP? This IP is nothing but the internal IP of this nodes. You can see that 160 10.1 160 is, you can see here. I forgot to add one more point. So while creating this load balancer, the stack is creating the load balancer with the round robin algorithm, which means that for every refresh, from each individual server, the request will be coming. Suppose in this page, the IP is 19. I'll open the same page in another tab. The request will be going to the 160 server. Now let's expand the cluster and check whether the load balancer is getting updated. Now we can see that only two nodes are there. One is 19 and one is 160. Let's expand. Expand. Yeah, the request is accepted successfully. We can see that the third node is still in build progress. Once it is active, the stack will automatically add the new node to the load balancer member. You can see that there's still two nodes here. Wait for some. Is creating. Yeah, the third node is successfully up and active. Now this node should have been added to the load balancer member. Yeah, we can see that the third node has been successfully added. Before only this 160 and 19 was there. Now 184 has been added. The third server. Yeah, we can see that we are able to see 184 also. So totally 3 nodes are running. Each time when I refresh, the request is going to every individual nodes. Now it's confirmed that the auto scaling with load balancer is successfully working. At the same time, let's try to shrink it and see whether the member has been removing successfully. Like how it was adding. So now out of 3 nodes, 1 node would have been removed. Yeah, we can see that it isn't deleting. The status isn't deleting. Once it gets deleted successfully, the node load balancer members will be updated automatically. Immediately. The third node has been removed successfully. Let's check the load balancer members list. Yeah, we can see that the third node has been successfully removed and only 2 nodes are here, which means that auto scaling with load balancer is working. So that's all. This is what auto scaling with load balancer means. We are able to see only 160 and 184. Okay. In this demo, I hope we saw how to create a cluster, health recovery in real time, which was auto healing, and load balancer updating dynamically during scale out and scale in. Okay, that's all from my side. Oh, I would be happy to answer any questions if anybody have any questions.
Thank you, Linkit, for the session.
Okay, thank
Yeah,
you.
so I had one question, Likit.
Yeah.
So Likit, so when you expanded, right? So the opened URL that you had, when you refreshed, it was only going to the same nodes, but then to the same application. It did not go to the third one. You had to copy the new load balancer URL. So did the load balancer get updated or the IP changed?
No, IP would be remaining the same. Only one extra node will be added to the existing load balancer members list. I just closed the tab.
So in that case, when you did a refresh, right, you had two tabs open. When you refreshed, it did not refresh, and you had to go back and then copy the load balancer IP again and then paste it.
No,
So that's what I wanted to know. What was the reason for it?
No, it was the same IP, 170, right? It was the same VIP, load balancer IP only.
Okay. But yet it did not refresh, right, Ajit, for some reason?
Yeah.
Just wanted to know if you know.
No, it was refreshing.
Actually, once the member has been added, it immediately doesn't show in that web page. It takes like around 5 to 6 minutes. Even though the member is added.
Okay, it was just a delay.
Yeah, exactly.
Or maybe it was just the HTML that was cached because it's the same HTML, so it just refreshed and then showed the same HTML. Is that it?
That may be browser caching also, because once it is cached, it will hit the same. Uh, so the third member, when it got added, it will take some time. Behind the scenes, it is getting added to the load balancer, right? Once it is added, then even if you refresh the same page, it might come. But I think he wanted to save some time and open a new tab and show you.
Yeah, exactly.
Okay, great. Thanks. Thanks, Ricky. And thanks, Ajit, for organizing this.
Thank you. Any other questions?
Yeah, none from mine.
Okay, if no questions, I'll just take over once again. Thanks, Likit, for a good session. Demo was good. Only the in between break of teams disturbed few things. But again, thank you once again. It was very good. So we had so we had a wonderful meetup today. Two wonderful sessions. I think all attendees would have got good takeaway from today's session. So I'm just going back to my own thing once again. So it is nice to see such sessions, and also it would be great to have more such speakers with more such interesting sessions. So that is something which I'm going back to, and we are calling for more volunteers who can share their experiences, success stories that will help growing the community in India. So this is a kind of a revival which we are having in 2025. It was a very quite active meetup group till COVID, and few things after COVID it went into a silent mode, and then again we are trying to revive. So we are slowly seeing this is the fourth meetup this year, and every meetup we are seeing a lot of interest coming in. And likewise we want to create a larger speaker pool so that we can have a pool of speakers who, for the whole year. And also we wanted to convert this event slowly into offline mode. I'm not sure how many of you are in Bangalore, But location definitely is not an issue. Even if it is, if you are in different cities, we can definitely conduct physical events, offline events like this. And if anybody is interested, definitely please reach out to us. Our coordinates are given here. You can see if anybody wants to contact me. Yes, this is my number. And we have Seshu Kumar's number here, and Nilesh from Pune is also there. So you can contact any one of us and let us know your interest to volunteer and conduct events. So birthday event for OpenStack 15th birthday, that is something which we are very aggressively planning. Though we had very initial discussions, nothing is finalized yet. So our target is to conduct an offline event in Bangalore and Pune. Bangalore is something very certain in August. Pune, we are yet to confirm. And if anybody from any other city wants to conduct a meetup, offline meetup with OpenStack 15th birthday celebration, please let us know, so that we'll have, because we have support from Open Infra Foundation as well. If somebody wants to volunteer and conduct an offline event, so that will be great exposure for everyone, and to grow this community in a larger scale. So I would like to invite everybody who would like to volunteer. Yeah, that's my request. So please help us. You can also share this information with your within your team or within your circle, so that we gather more and more people in coming days. So that's from my side. So thanks for the speakers, thanks for the attendees for taking your time today on a Wednesday. Again, we are open for suggestions because this is Wednesday, something which we started. We wanted to know whether it is convenient, not convenient, because we are open to all changes. So nothing is static here. So as and when we start receiving more and more suggestions and ideas, we are open to adopt that as well. Once again, thank you all for attending today's meetup. Great. Thank you.
Thanks, Ajit.
Bye.
Thank you.